Triangle congruence by SSS. Previously we talked about how when you have congruent polygons, you need to know that every single side of one corresponds to and is congruent to another side of the other polygon. And then every single angle has to correspond and be congruent to another angle in the other polygon. Then when all the angles and all the sides are corresponding, then you can write a congruent statement. However, the question is, how much do you need to know about two triangles to prove that they are congruent? So we're not talking about polygons in general, we're specifically talking about triangles. There are 5 postulates that help us identify the minimum amount of information to determine whether or not two triangles are congruent. And right now we're going to talk about one of them. Side, side, side congruence postulate, otherwise known as SSS. So if 3 sides of one triangle are congruent to 3 sides of another triangle, then that's enough information to say that the two triangles are congruent. So if you have 2 triangles and you have 3 sets of corresponding and congruent sides, you don't have to have any information about the angles. Knowing that the 3 sides of one are congruent to 3 sides of another triangle is enough information to say that those two triangles are going to be congruent. Can you use SSS to prove these triangles congruent? Your answer choices are yes, no, and not enough information. If your answer is yes, write a congruent statement. So let's walk through these. When we look at these first 2 triangles, we have one side marked with 1 that corresponds to this one. This 2 corresponds to this one. And this side marked 3 corresponds to this one. So since we have 3 sets of corresponding sides, we can say yes, the triangles are congruent. So then we need to write a congruent statement. So again, we practiced this before. We're going to say triangle, if we say RSQ, now the first one doesn't matter what order it goes in, but we went from R to S, that's the side length marked with 2, and then from S to Q, the side marked with 3. So we need to go in that same order. X to W is marked with 2, W to Y is marked with 3. So in that same order, this is congruent to triangle X, W, Y. Now we're going to take that same idea with the second set of triangles. We have one side marked with 2, and it corresponds to this side marked with 2. Another side marked with 2, which corresponds to this side marked with 2. And then lastly, we have another side marked with 2, but over here, this side is only marked with 1. Having 2 pairs of congruent sides is not enough. You have to have all 3 sides congruent to all 3 sides. So since we know that all 3 sides are not congruent to each other, we can say for sure that these 2 triangles are not congruent. Let's look at this next pair down here. Now it looks promising because this side is congruent to this one and this one is congruent to this one. So far so good. And the pictures honestly look like they're congruent. They look like isosceles triangles where the bases are the same length. However, and this is really important, so you need to listen carefully, if these third sides do not have markings, you cannot add them. You cannot add additional side markings unless you have a theorem or a postulate to back it up. And since we don't have any reason to say that those are the same, we don't have enough information. So we can put any I, which stands for not enough information. We cannot say whether these 2 triangles are congruent because you don't know anything about that third side. So again, you need to be very, very careful about not adding extra information here. When we look at this last set of triangles, they are adjacent because they're sharing a side. So we have that side is congruent to this one, this side is congruent to that one. Now I know what you're thinking. We're in that same situation where we don't have markings on that third side, and it seems like it's the same as this set of triangles. However, if you look very carefully, that third side where they're adjacent, from A to C, it's exactly the same. So this is where we actually use the reflexive property, and we say that segment AC is congruent to segment AC, because it's going to be the same length whether it's on this triangle or this triangle. So this one, because it's supported by the reflexive property, we can say that it's congruent to itself, and so now we have 3 sets of corresponding and congruent sides. So the answer is yes, these triangles are congruent. And again, we need to write the congruence statement. So if we say triangle ABC is congruent to triangle, so again, in that same order, A to B is 1, B to C is 2. So we need to go 1, 2. So we go CDA, triangle CDA. That's it for this lesson, so make sure you paid close attention to this. Next time we'll talk about the other 4 congruence postulates that give you the minimum amount of information to say that 2 triangles are congruent.